Welcome to Chapter 2, Acids, Bases, and Salts. This chapter covers 5 key topics. First, acids and bases, their properties, indicators, and what they have in common. Second, chemical reactions, reactions of acids and bases with metals, oxides, and carbonates. Third, the pH scale, measuring acidity and basicity, and its importance in daily life. Fourth, salts, their families, pH, and water of crystallization. Fifth, important compounds, common salt, baking soda, washing soda, bleaching powder, and plaster of Paris. Acids are substances that produce H+, or hydrogen ions, when dissolved in water. In water they exist as H3O+, called hydronium ions. Common laboratory acids include hydrochloric acid, sulfuric acid, nitric acid, acetic acid in vinegar, and carbonic acid in fizzy drinks. Natural acids, citric acid in lemon, tartaric acid in tamarind, acetic acid in vinegar, oxalic acid in tomato, and lactic acid in curd. Properties of acids: sour taste, corrosive, they turn blue litmus paper red, and their pH is less than 7. Bases are substances that produce OH-, or hydroxide ions, when dissolved in water. Common bases include sodium hydroxide, commonly called caustic soda, calcium hydroxide, commonly called slaked lime, magnesium hydroxide, commonly called milk of magnesia, and ammonium hydroxide. An alkali is a base that is soluble in water. All alkalis are bases, but not all bases are alkalis. Sodium hydroxide and potassium hydroxide are alkalis. Copper hydroxide is a base, but not an alkali, because it is insoluble. Properties of bases: bitter taste, soapy feel, they turn red litmus paper blue, and their pH is greater than 7. Indicators are substances that change color, in acids and bases. They help us identify whether a solution is acidic or basic. Litmus, extracted from lichen, red in acid, blue in base, and purple in neutral solution. Turmeric, yellow in acid and neutral, but red or brown in base. Hibiscus, pink or red in acid, and green in base. Red cabbage juice, beetroot juice, and onion juice are also natural indicators used in the laboratory. Methyl orange, red in acid and yellow or orange in base. Phenolphthalein, colorless in acid or neutral, and pink in base. Universal indicator, a mixture of several indicators that gives a range of colors for pH 1 to 14. It allows us to estimate the approximate pH of a solution. Litmus and methyl orange only tell us acid or base, 2 states. Universal indicator gives a continuous color scale from red through green to violet. A strong acid completely dissociates in water, producing a large concentration of H+ ions. Examples: hydrochloric acid, sulfuric acid, and nitric acid. A weak acid only partially dissociates, producing a small concentration of H+ ions. Examples: acetic acid, carbonic acid, and phosphoric acid. Concentrated versus dilute refers to the amount of acid dissolved, not its strength. Dilute hydrochloric acid is strong but dilute. Concentrated acetic acid is weak but concentrated. Strong or weak refers to degree of ionization. Concentrated or dilute refers to amount of solute. These are independent properties. When acids react with metals, they produce a salt and hydrogen gas. General equation: acid plus metal gives salt plus hydrogen. Zinc solid plus sulfuric acid gives zinc sulfate plus hydrogen gas. Iron solid plus sulfuric acid gives iron sulfate plus hydrogen gas. Magnesium plus 2HCl gives magnesium chloride plus hydrogen. 2 aluminium plus 6HCl gives 2 aluminium chloride plus 3 hydrogen. Test for hydrogen: hold a burning splint near the mouth of the tube. A pop sound confirms hydrogen. Watch out this video. Did you hear the pop sound? Note: less reactive metals like copper, silver, and gold do not react with dilute acids. When acids react with metal oxides, they produce a salt and water. Metal oxides are basic, they neutralize acids. General equation: acid plus metal oxide gives salt plus water. Copper oxide solid plus sulfuric acid gives copper sulfate plus water. The black copper oxide dissolves and a blue copper sulfate solution forms. In this video, you can see the beautiful formation of blue solution. Copper oxide plus hydrochloric acid gives copper chloride plus water. Zinc oxide plus sulfuric acid gives zinc sulfate plus water. All metal oxides, being basic oxides, react with acids to give salt and water. The color change from black to blue-green is visible confirmation. Acid plus metal carbonate gives salt plus water plus carbon dioxide gas. Acid plus metal bicarbonate also gives salt plus water plus carbon dioxide. Sodium carbonate plus 2 hydrochloric acid gives 2 sodium chloride plus water plus carbon dioxide. Calcium carbonate plus 2 hydrochloric acid gives calcium chloride plus water plus carbon dioxide. Sodium bicarbonate plus hydrochloric acid gives sodium chloride plus water plus carbon dioxide. Test for carbon dioxide: pass the gas through lime water. The lime water turns milky as insoluble calcium carbonate precipitates. Calcium hydroxide plus carbon dioxide gives calcium carbonate precipitate plus water. Neutralization is the reaction between an acid and a base to produce a salt and water. The H+ ion from the acid combines with the OH- ion from the base to form water. Hydrochloric acid plus sodium hydroxide gives sodium chloride plus water. Adding phenolphthalein to sodium hydroxide turns solution pink, indicating its base nature. If we keep adding hydrochloric acid, the solution becomes colorless. It indicates neutralization. The solution is no longer basic. Sulfuric acid plus 2 potassium hydroxide gives potassium sulfate plus water. Nitric acid plus sodium hydroxide gives sodium nitrate plus water. 2-hydrochloric acid plus calcium hydroxide gives calcium chloride plus 2 water. Neutralization is exothermic, the mixture warms up. At the equivalence point, neither acid nor base is in excess. Dry hydrogen chloride gas does not turn blue litmus red. Hydrogen chloride dissolved in dry toluene does not conduct electricity. When dissolved in water, hydrogen chloride gives H+ and chloride ion. The H+ ion, or hydronium ion, is responsible for all acidic properties. Similarly, sulfuric acid gives 2H+ and sulfate ions. Nitric acid gives H+ and nitrate ions. All acids share the same H+ ion in aqueous solution, this is what makes them acidic. Conclusion: acids produce H+ ions only in the presence of water. Water is essential for acidic behavior. Dilution means adding water to acid, which decreases the concentration of H+ ions per liter. Safety rule: always add acid to water, never add water to concentrated acid. Adding water to concentrated sulfuric acid is highly exothermic and causes dangerous spattering. Dilution raises the pH of an acid towards 7. The more water added, the fewer H+ ions per liter and the higher the pH. But dilution alone can never make an acid basic, pH greater than 7. What is common in all bases? All bases produce OH- ions in water. Sodium hydroxide gives sodium ion plus OH-. Potassium hydroxide gives potassium ion plus OH-. Calcium hydroxide gives calcium ion plus 2 OH-. The OH- ion is responsible for all basic properties. Bases also require water to show basic behavior, just as acids require water to show acidic behavior. Key conclusion: both acids and bases need water to show their properties. Without water, neither H+ nor OH- ions are produced. Water is the essential medium for both. Certain amphoteric metals, such as zinc and aluminium, react with strong bases to produce hydrogen gas. General form: base plus metal gives salt plus hydrogen. Zinc solid plus 2 sodium hydroxide gives sodium zincate aqueous plus hydrogen gas. 2 aluminium plus 2 sodium hydroxide plus 2 water gives 2 sodium aluminate plus 3 hydrogen gas. Most metals like iron, copper, and magnesium do not react with bases. Only amphoteric metals, zinc, aluminium, tin, and lead, do. Non-metal oxides are acidic in nature, they react with bases to form salt and water. General form: base plus non-metal oxide gives salt plus water. Calcium hydroxide aqueous plus carbon dioxide gives calcium carbonate precipitate plus water. This is the lime water test, it turns milky. 2 sodium hydroxide plus carbon dioxide gives sodium carbonate plus water. 2 sodium hydroxide plus sulfur dioxide gives sodium sulfite plus water. This mirrors the reaction of acids with metal oxides, a perfect symmetry. Basic oxides react with acids, acidic oxides react with bases. pH is a number that indicates the concentration of H+ ions in a solution. The scale runs from 0 to 14. pH less than 7 is acidic. pH equals 7 is neutral. pH greater than 7 is basic. Higher the H+ concentration, lower the pH, more acidic. Lower the H+ concentration, higher the pH, more basic. Examples: gastric acid has pH 1 to 2. Lemon juice has pH 2 to 3. Pure water has pH 7. Blood has pH 7.4. Baking soda has pH 8 to 9. Sodium hydroxide solution has pH 13 to 14. pH stands for power of hydrogen. Each unit change in pH represents a 10 times change in H+ concentration. Our stomach secretes hydrochloric acid at pH 1 to 2 to activate enzymes and kill bacteria. Too much acid causes indigestion. Antacids are weak bases that neutralize excess hydrochloric acid. Examples: magnesium hydroxide, milk of magnesia, sodium bicarbonate, and aluminium hydroxide. Tooth decay: bacteria in the mouth digest food sugars and produce acids. When pH drops below 5.5, tooth enamel, which is calcium phosphate, starts dissolving. Toothpastes are mildly basic, they neutralize the acid produced by bacteria and protect the enamel. Soil pH and plant growth: most plants grow well at pH 6 to 7. Acidic soil is treated with quicklime or slaked lime. Alkaline soil is treated with organic matter like compost. Acid rain: sulfur dioxide and nitrogen dioxide from industries dissolve in rainwater to form sulfuric and nitric acids, giving acid rain with pH less than 5.6. Acid rain damages crops, buildings, and aquatic life. Self-defense by plants: the nettle plant injects formic acid through stinging hairs causing pain. Applying dock leaf juice, which is basic, to the sting gives relief. Insect stings. Bee sting is acidic, formic acid, so apply a base like baking soda. Wasp sting is alkaline, so apply an acid like vinegar. Our body maintains pH within very narrow ranges. Blood, pH 7.35 to 7.45, slightly basic, a deviation of even 0.2 units can be fatal. Stomach, pH 1.5 to 3.5, strongly acidic, needed for digestion. Saliva, pH 6.5 to 7.5, neutral to slightly acidic. Urine, pH 4.6 to 8.0, varies with diet and health. Hydrangea flowers change color with soil pH. Acidic soil gives blue flowers, alkaline soil gives pink flowers. The aluminium ion released in acidic soil causes the blue pigment. Enzymes in our body have an optimum pH. Pepsin works best at pH 1.5 to 2 in the stomach. Salivary amylase works best at pH 6.8 to 7 in the mouth. A salt is formed when the H+ of an acid is replaced by a metal ion, through neutralization or reaction with metal or oxide. Family of sodium chloride salts: sodium chloride, sodium sulfate, sodium nitrate, sodium carbonate, all sodium salts from different acids. Family of calcium salts: calcium chloride, calcium sulfate, calcium nitrate, calcium carbonate. pH of salts: strong acid plus strong base gives a neutral salt at pH 7, examples: sodium chloride, potassium sulfate. Strong acid plus weak base gives an acidic salt, pH less than 7, examples: ammonium chloride, copper sulfate. Weak acid plus strong base gives a basic salt, pH greater than 7, examples: sodium carbonate, sodium acetate. Not all salts are neutral. The pH of a salt solution depends on the relative strengths of the acid and base used to make it. Water of crystallization is a fixed number of water molecules chemically bonded within the crystal structure of a salt. It is written after a dot in the formula. Copper sulfate pentahydrate, CuSO4.5H2O, blue vitriol, blue crystals. Iron sulfate heptahydrate, FeSO4.7H2O, green vitriol, green crystals. Sodium sulfate decahydrate, Na2SO4.10H2O, Glauber's salt. Calcium sulfate dihydrate, CaSO4.2H2O, gypsum, used to make plaster of Paris. When blue vitriol is heated, it loses its water of crystallization and turns white, anhydrous copper sulfate. Adding water back restores the blue color. Common salt, sodium chloride or NaCl, is a neutral salt with pH 7. It is an essential mineral for life. Sources: seawater, which contains about 3.5% dissolved salts. Rock salt from underground deposits. Salt lakes like Samhar Lake in Rajasthan. Uses: food preservation and seasoning. It is also the raw material for making sodium hydroxide, sodium carbonate, sodium bicarbonate, hydrochloric acid, and chlorine. Sodium chloride is the raw material for the chlor-alkali process, one of the most important industrial chemical processes. The chlor-alkali process is the electrolysis of brine, concentrated sodium chloride solution, to produce three important products. The reaction, 2 sodium chloride plus 2 water gives 2 sodium hydroxide plus chlorine gas plus hydrogen gas. At the cathode, negative electrode, hydrogen gas is produced. At the anode, positive electrode, chlorine gas is produced. Sodium hydroxide remains in solution. It is called chlor-alkali because chlorine and an alkali, sodium hydroxide, are the main products. These provide key raw materials for many industries. 3 products from the chlor-alkali process, each with major industrial uses. Sodium hydroxide or caustic soda, making soaps and detergents, paper, artificial fibers like rayon, degreasing metals, and drain cleaners. Chlorine, disinfecting drinking water and swimming pools, manufacturing bleaching powder, PVC, CFCs, pesticides, and hydrochloric acid. Hydrogen, manufacturing ammonia through the Haber process for fertilizers, fuel cells, and hydrogenation of oils to make margarine. Hydrochloric acid is made from the chlorine and hydrogen produced. H2 plus Cl2 gives 2HCl. Bleaching powder is calcium oxychloride, formula CaOCl2. Preparation: chlorine gas is passed over dry slaked lime, calcium hydroxide, at 40 degrees Celsius. Calcium hydroxide plus chlorine gives calcium oxychloride plus water. Uses: bleaching cotton, linen, and wood pulp in textile and paper industries. Disinfecting drinking water. Used as an oxidizing agent in chemical industries. Bleaching action: the compound reacts with water to release hypochlorous acid, which releases nascent oxygen. This nascent oxygen does the actual bleaching. Baking soda is sodium hydrogen carbonate, or sodium bicarbonate, NaHCO3. Chemical name: sodium hydrogen carbonate. Its pH is slightly above 7, mildly basic. Preparation by the Solvay process: sodium chloride plus water plus carbon dioxide plus ammonia gives sodium bicarbonate precipitate plus ammonium chloride. On heating, 2 sodium bicarbonate gives sodium carbonate plus water plus carbon dioxide. The carbon dioxide released makes dough rise in baking. Baking powder equals baking soda plus a mild edible acid like cream of tartar or tartaric acid. The acid reacts with sodium bicarbonate on contact with water, giving faster carbon dioxide release. Sodium bicarbonate has diverse applications, 1. Baking, it is a leavening agent. Carbon dioxide released on heating makes bread, cakes, and pastries light and fluffy. 2. Antacid, it neutralizes excess hydrochloric acid in the stomach and relieves indigestion. Sodium bicarbonate plus hydrochloric acid gives sodium chloride plus water plus carbon dioxide. 3. Fire extinguisher, it reacts with sulfuric acid to produce carbon dioxide, which smothers the fire. Also used in effervescent drinks and as a mild antiseptic. Washing soda is sodium carbonate decahydrate, Na2CO3.10H2O. It is a basic salt with pH greater than 7. Preparation from baking soda. Step 1. Heat 2 sodium bicarbonate to get sodium carbonate plus water plus carbon dioxide. Step 2. Dissolve sodium carbonate and recrystallize by adding water to get washing soda crystals. Sodium carbonate hydrolyzes in water releasing OH- ions, which makes the solution basic. Washing soda is a hydrated salt with 10 molecules of water of crystallization. In dry air, the crystals effloresce, they lose their water and become anhydrous sodium carbonate, soda ash. Sodium carbonate decahydrate has wide domestic and industrial uses. 1. Cleaning agent. The basic solution removes grease and oils from clothes by hydrolyzing fats. 2. Water softening. It removes temporary and permanent hardness by precipitating calcium and magnesium as their carbonates. Calcium chloride plus sodium carbonate gives calcium carbonate precipitate plus 2 sodium chloride. 3. Glass, soap, and paper industries, raw material and manufacturing. 4. Used to make borax, sodium tetraborate, for pottery glazes and as a flux. Gypsum is calcium sulfate dihydrate, CaSO4.2H2O, a soft white mineral with 2 molecules of water of crystallization. Preparation. Gypsum is heated to 100 degrees Celsius. It loses 1.5 water molecules to give calcium sulfate hemihydrate plus 1.5 water. This is plaster of Paris. Plaster of Paris, POP, is calcium sulfate hemihydrate, CaSO4.2H2O. It is a white powder. Important, if heated above 120 degrees Celsius, gypsum forms anhydrous calcium sulfate, dead burnt plaster, which can no longer set with water. Temperature control during preparation is critical. Setting of plaster of Paris. When mixed with water, POP rehydrates back to gypsum and sets hard. CaSO4.2H2O plus 1.5 H2O gives CaSO4.2H2O. The setting reaction causes a slight expansion, so POP fills the mold cavity perfectly, giving crisp details. The setting is also exothermic. Uses: orthopedic casts for broken bones, making statues and decorative items. Also used for making blackboard chalk, dental impressions in dentistry, fireproofing materials, and smooth plaster finish on walls. Quick reference: how each indicator behaves in acid and base. Litmus: red in acid, blue in base, purple in neutral. Methyl orange: red in acid, yellow in base. Phenolphthalein: colorless in acid and neutral, pink in base. Turmeric: yellow in acid, red-brown in base. Hibiscus: pink or red in acid, green in base. Universal indicator: shows a full color range from pH 1 to 14. Phenolphthalein is most reliable for detecting bases. Litmus is the most commonly used for both acids and bases. Quick reference: acid reactions and their products. Acid plus metal gives salt plus hydrogen. Acid plus metal oxide gives salt plus water. Acid plus metal carbonate gives salt plus water plus carbon dioxide. Acid plus metal bicarbonate also gives salt plus water plus carbon dioxide. Acid plus base, neutralization, gives salt plus water. Gas tests: hydrogen gives a pop with a burning splint. Carbon dioxide turns lime water milky. All these important compounds are made from common salt, sodium chloride. Sodium hydroxide, NaOH, common name is caustic soda, used in soap, paper, and textiles industry. Sodium bicarbonate or sodium hydrogen carbonate, NaHCO3, common name is baking soda, used in baking, antacid, fire extinguisher. Sodium carbonate, Na2CO3.10H2O, common name is washing soda, used in cleaning, water softening. Calcium oxychloride, CaOCl2, common name is bleaching powder, used in bleaching and disinfecting. Calcium sulfate hemihydrate, common name is plaster of Paris or POP, used in making casts, statues, and dentistry. The chain, NaCl by electrolysis gives NaOH. NaOH plus CO2 gives Na2CO3. Na2CO3 gives NaHCO3. All linked in one chain starting from common salt. Side-by-side comparison of key properties of acids and bases. Taste: acids are sour, bases are bitter. Feel: acids are corrosive, bases are soapy and slippery. Ion produced in water: acids give H+, bases give OH-. Effect on litmus: acids turn blue litmus red, bases turn red litmus blue. pH: acids have pH less than 7, bases have pH greater than 7. Reaction with metal: acid gives salt and hydrogen gas. Most base don't react with metal, except a few like zinc and aluminium. The one thing in common for both acids and bases: both require water to show their properties. Hydrated salts, remember name, formula, water molecules, and color. Blue vitriol, CuSO4 with 5 water molecules, blue in color. Green vitriol, FeSO4 with 7 water molecules, green in color. White vitriol, ZnSO4 with 7 water molecules, white in color. Gypsum, CaSO4 with 2 water molecules, white in color. Plaster of Paris, CaSO4 with half water molecule, it means 2 molecules of salt share 1 molecule of water, it is a white powder. Washing soda, Na2CO3 with 10 water molecules, white crystals. Borax, Na2B4O7.10H2O. When a hydrated salt is heated, it loses its water of crystallization and becomes anhydrous, it loses its color and turns white. Core ideas discussed in this chapter. 1. Acids produce H+ ions in water, bases produce OH- ions. Water is essential for both to show their properties. 2. Acid plus base gives salt plus water, neutralization. Acid plus metal gives salt plus H2. Acid plus carbonate gives salt plus H2O plus CO2. 3. pH scale from 0 to 14. Correct pH is crucial for digestion, tooth health, plant growth, and survival. 4. Chloralkali process. Electrolysis of brine gives NaOH plus Cl2 plus H2. These 3 products are the basis of dozens of industries. 5. Plaster of Paris from gypsum sets hard on adding water. Water of crystallization is part of the crystal structure, not free water.